In the middle of a violent storm, the pilots of a Boeing 737 are in a desperate fight for survival. Their plane is plunging into the ocean at almost the speed of sound. Can they regain control before time runs out for them and their 100 passengers? What follows is a devastating tale of corruption on the ground and chaos in the air. This is the harrowing story of Air Flight 574. On New Year's Day 2007, 96 passengers and 6 crew members boarded an Air Boeing 737 at Juanda International Airport in Surabaya, Indonesia. They were bound for Manado in the north of the country. Most of the passengers were Indonesians returning home after the holidays, but there was also an American family of 3 and a passenger from Germany. As the passengers settled in for the 2-hour flight, the pilots began preparing the aircraft for takeoff. Commanding the flight was 47-year-old Captain Rafri Widodo. He had joined Air just 6 months earlier, but had been flying for decades. He had accumulated more than 13,000 hours of flight time. Sitting to his right was 36-year-old First Officer Yoga Santoso. He had about 4,000 hours in total, including just under 1,000 hours on the 737. Both pilots had come through Air's training program without any serious problems. But as we'll see, Air was no ordinary airline. Everything from its pilot training to its maintenance and engineering practices were notoriously poor, even in Indonesia, a country with a less than stellar aviation record. Air was an outlier. That's why, while what happened to Flight 574 was shocking, the fact that it happened was anything but. What we're about to see is what happens when pilots who are products of this system are confronted with a situation for which they are neither trained nor mentally prepared. And it all started on the ground in Surabaya, as the flight crew set up their navigation equipment for the flight to Manado. Even on a relatively modern aircraft like the 737-400, pilots still use a rather old technology to determine their position in space. In fact, they use a technology that predates GPS. It is called an IRS, or Inertial Reference System. It uses 3 gyroscopes, each of which measures the plane's acceleration along a dimension. Once the pilots tell the system the aircraft's starting position, the IRS combines the information from the 3 gyros to accurately determine the aircraft's position as it moves across the planet. However, the IRS is a sensitive instrument and requires maintenance. Air was notorious for its shoddy maintenance practices. In the 3 months prior to this flight, over 150 recurring defects were recorded in the logbook of this aircraft alone, including repeated problems with the IRS, problems with the captain's vertical speed indicator, random disengagement of the autopilot in flight, and an unreliable weather radar. Modern aircraft are complicated machines and small technical problems are common, but this level of malfunction over an extended period of time was and will prove to be criminal. When the pilots prepared Flight 574 for takeoff, they were well aware that this aircraft had problems with its inertial reference system. What they weren't prepared for and couldn't be prepared for were the limitations of their own training, which would become all too apparent as they headed out over the Java Sea. At 14:42 that afternoon, Flight 574 pushed back from the gate at Surabaya, its 98 passengers settling in for the short trip north, most of them looking forward to being home for dinner. This part of the world may be known for its beaches and sunshine, but it is also home to some of the most dangerous storms on the planet. As the pilots taxied out to the runway at Surabaya, they knew that the flight ahead would require them to carefully navigate their way around these storm clouds. It was and is a simple fact of life for Indonesian pilots, and nothing the experienced crew of Flight 574 couldn't handle. But there was more than storms in store for this crew. At 2 p.m. that day, the captain lined up the plane with the runway and set the engines to takeoff thrust. The plane lurched into the stormy skies and began its journey northeast towards Manado. As the pilots climbed to their cruising altitude of 35,000 feet, everything went according to plan. They engaged the autopilot, which followed the route programmed into the flight management system, located here in the cockpit. The flight management system, or FMS, is at the heart of how pilots fly modern aircraft. They use it to monitor their progress along their route, make changes to their route, and monitor their fuel consumption, among other important aspects of flight operation. Captain Widodo and First Officer Santoso had programmed in their route while the plane was at the gate in Surabaya. This route was now shown in map format by the magenta line on this display. Normally, the autopilot, or the pilot, doesn't have to do much with the controls to keep an aircraft flying in a straight line along this route. Planes are generally so stable that they'll fly pretty much in a straight line on their own, autopilot or no autopilot. But this being Atom Air, things weren't quite so simple. Due to an unresolved maintenance issue with the plane's ailerons, the control surfaces on the wing that turn left and right, the plane had a tendency to roll to the right. To correct this, the autopilot had to constantly hold the control column slightly to the left. This was annoying, but as long as everything else was going normally, it shouldn't have caused any major problems. As the aircraft climbed out over the Java Sea, the pilots noticed something unusual. The captain's and first officer's flight management systems showed the aircraft in different locations. The pilots immediately knew what had to be the culprit. The 737 has two independent inertial reference units, one of which feeds information to the captain's flight management system, while the other feeds information to the first officer's system. This redundancy is what makes the flight so safe and reliable. But the problem facing the pilots of Flight 574 was that they didn't know which of these systems to believe. Both seemed to give plausible locations for the plane. One of the inertial reference units was feeding false information into one of the flight management computers. But which one was it? And crucially, the difference between the two locations was growing. Every minute the pilots had to work out where they were going, otherwise they would be lost over the ocean. Incredibly, this was the fate that befell another Atom Air crew less than a year earlier. The pilots of that flight were lost over the ocean at night after one of their inertial reference units failed. It took them 2 hours to find their way back to an airport, by which time they were dangerously low on fuel. So when the pilots of Flight 574 first spotted the IRS problem, they knew the clock was ticking. They had to figure out where they were, and they had to do it as huge thunderstorms began to gather around them. They could only hope that the plane's faulty weather radar hadn't failed as well. Back in the main cabin, the passengers were completely unaware of what was happening up front. The pilots they had trusted with their lives had no idea where their plane was, and they were about to fly into a storm cloud. The captain told the passengers to fasten their seatbelts, and shortly afterwards the plane entered the cloud. From here, their situation would only get worse. What you're about to hear is an excerpt from the cockpit voice recorder, which captured the pilots' confusion as they tried to deal with the problem. The pilots were joking to ease the tension, but there was no denying that their situation was serious and getting worse. The captain then asked the first officer to see if air traffic control had a fix on their position. This must have seemed an odd request to the controller, to say the least. Pilots often ask controllers for things like current weather information, but for a pilot to ask a controller where he was should have set off alarm bells. Something was seriously wrong with Flight 574. Mike Kilo Sierra, a radio beacon. The controller told them they were 125 miles from the beacon and on a heading of 307 degrees from it, which is roughly northwest. The pilots now had a chance to rectify their problem. They could see whether the controller's report matched the captain's or the first officer's instruments better. But for some reason they never did. They simply continued to be confused by the desperate FMS readings. But the first officer didn't want the controller to know they were having problems, so he said, "The confusion in the cockpit only deepened. It would have been very simple for the pilots to tune their navigation radios to the frequency of the Mike Kilo Sierra beacon and check its range against their two flight management systems to see which was correct. But they didn't. Both pilots were so fixated on finding the cause of the faulty IRS that they didn't think to prioritize the most important thing, finding out where they actually were. Here was an opportunity for the captain to take a step back and reassess their options. This was his responsibility as leader of the two-man team, but he didn't do it. Instead, he and the first officer continued to zoom in on the problem. The fact that they were flying deeper and deeper into the thunderstorms only made their situation more urgent. After minutes of confusion and half-hearted troubleshooting, the captain realized it would probably be best to find out if there were any procedures for dealing with an IRS failure. He ordered the first officer to check the QRH, or Quick Reference Handbook, to see if he could find anything. After leafing through the manual, the first officer finally found a section entitled IRS Fault. At last, they had a procedure to follow, something that could finally put an end to their confusion. This is the actual checklist that the pilots used. The steps were fairly straightforward, but this simplicity hid the fact that the procedure would require a great deal of attention on the part of the pilots. Here's why. The first step was to turn the IRS mode selector on the faulty IRS, shown here, to the ATT, or attitude position. When this happened, the first officer's attitude indicator here would go blank, and importantly, the autopilot would disconnect. It would then be up to the captain to fly the aircraft manually using his instruments while the first officer continued with the checklist. The checklist required the aircraft to be kept level for 30 seconds while this was being done. Again, this was a straightforward procedure that simply required one pilot to hold the aircraft level for 30 seconds while the other rebooted the system. But here the captain's fixation on the IRS would put him and everyone else on board in serious danger. When the first officer turned the IRS mode selector to the attitude position, his attitude indicator went blank and the autopilot disengaged. But instead of taking manual control of the aircraft, one of the pilots reflexively silenced the alarm, and the captain continued with his head up in the canopy, monitoring the first officer as he carried out the procedure. And this is where the small problem we had encountered earlier would begin to have an outsized effect. As the crew went through the checklist, the autopilot, now disengaged, was no longer correcting the aircraft's tendency to roll to the right. Slowly, imperceptibly at first, the aircraft began to turn. Deep in the clouds, there was no way for the pilots to see that their aircraft was turning just by looking out the window. It was up to the captain to keep an eye on his instruments to see that this was happening, but he didn't, and the first officer's instruments were blank. Second by second, the plane continued to bank to the right. When 30 seconds had passed, the pilots were puzzled as to why the first officer's displays were still blank. Why had the system not restarted? Little did they know that the reason was that the captain had not held the aircraft steady during the IRS checklist, but the faulty IRS was to be the least of their worries. Within seconds, the plane had reached 35 degrees of bank, and an automated voice called out, bank angle, pitch." This alerted the pilots that they were beginning to roll far too far to one side. They had to level the aircraft immediately, but the captain panicked. Instead of simply looking at his primary instruments and flying the plane, he hurriedly told the first officer to move the IRS switch back to the nav position. He hoped that would somehow reverse the problem they'd got themselves into. But then the altitude alert horn sounded, telling the crew that they were now leaving their selected altitude of 35,000 feet. The aircraft banked so far to one side that it began to slide down towards the ocean. This descent would soon become a dive. The first officer started to correct the aircraft's bank, but the captain warned him to stop. The captain still thought the plane was straight and level, and urged the first officer not to touch the controls because the plane needed to be level for the IRS to restart properly. But soon their situation became all too clear. Now came the most terrifying warning of all. Gra gra, yeah. With the aircraft now in a full dive, it was gaining tremendous speed and was now traveling at over 90% of the speed of sound. The overspeed warning was telling the pilots that if they didn't slow down now, parts of their plane would start to break off. The captain was in total panic at this point. His plane was heading straight for the ocean and he had no idea what to do. Adamir had not trained him in how to recover from what is known as an abnormal attitude. So, with no training to fall back on, he followed his instincts and simply pulled back on his control column. This had the effect of making the spiral dive even tighter, putting even more stress on the aircraft's structure. All hell had broken loose in the passenger cabin. Passengers were pushed hard into their seats by the extreme G-forces of the spiraling descent, as the engines roared and a near-supersonic wind howled past the fuselage. The aircraft was now descending at over 50,000 feet per minute. The first officer urged the captain to pull up, but the aircraft was now traveling too fast. Any significant movement on the controls risked tearing it apart, and when the captain pulled back on the control column, that's exactly what happened. The horizontal stabilizer at the rear of the aircraft was ripped off by the extreme force of the air. There was nothing the pilots could do. Their plane was uncontrollable. As the plane reached 9,000 feet, the cockpit voice recorder and flight data recorder went blank. Seconds later, Flight 574 crashed into the ocean at almost 1,000 kilometers per hour. All 102 people on board were killed instantly. It all happened so fast that the last position of the plane on the air traffic controller's scope showed it at its cruising altitude of 35,000 feet. But how did things get so bad that this accident could happen in the first place? What investigators from Indonesia's National Transportation Safety Committee uncovered was shocking. They discovered that the pilots of Flight 574 had received woefully inadequate training from Adamir, so much so that they had never been trained to deal with an IRS fault, or a fault in almost any other aircraft system. Not only had they not been trained to deal with these issues, but the manuals the airline gave its pilots were not the official Boeing manuals, but were simply printed off from one of Boeing's websites. Not only that, but these manuals were specifically marked as not for operational use. Investigators also found that the pilots hadn't been given what's known as upset prevention and recovery training, which is standard for airlines in other parts of the world and would have allowed the crew to easily recover from the dive when it first developed. When the plane first went into the dive, the captain could have saved it by simply rolling the plane until the wings were level and then pulling out of the dive. Instead, he pulled back on his control column, which only made the spiral dive worse. But perhaps worst of all, the captain's fixation on the IRS and his failure to delegate the cockpit workload meant that all it took was an unfortunate series of inconveniences to doom the flight. Investigators made a number of recommendations to prevent such an incident from happening again, including updating pilot training requirements and tightening aircraft maintenance regulations. Adamir went out of business a year after the crash of Flight 574. Of its 27 737s, 3 had been written off due to accidents. But that didn't make Indonesian aviation any safer. In 2021, another Indonesian 737 crashed in shockingly similar circumstances. Watch the video I made about this incident here to see how far the lessons of Flight 574 have yet to be learned.